Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology lecture videos. The topic of today's video is nanocrystalline and nanocomposite nanomaterials. But before I start today's video, I would like you to please subscribe to my channel if you have not done it so far, and to also share this video among all your friends and colleagues. So let's begin with the nanocrystalline nanomaterials first, followed by the nanocomposite nanomaterials. What are nanocrystalline materials? The nanocrystalline materials, abbreviated as capital NC, are polycrystalline with a crystallite size of only a few nanometers. These materials fills the gaps between amorphous and conventional coarse-grained materials without any long-range order materials. The grain sizes ranges between 100 to 500 nanometers and are considered as ultra-fine grains. What are nanocrystals and nanocrystalline materials? Explain. The nanocrystals are of two types, the layered nanocrystals and the filamentary nanocrystals. In the layered nanocrystal materials, the magnitudes of length and width is much greater than its thickness, whereas in the filamentary nanocrystals, the length is considerably larger than its width. On the other hand, the nanocrystalline materials could be crystalline, quasi-crystalline or amorphous phases, and it can be metals, ceramics or composites. State some important properties of nanocrystalline materials. The important properties include excellent mechanical properties such as super strength, super hardness, enhanced diffusivity, improved ductility, toughness, reduced density, and reduced elastic modulus. The example of high strength in combination with good ductility is nickel iron armor plating, which is twice as tough as the requisite specifications for military vehicles when made in nanocrystalline form. The other important characteristics are enhanced tribological characteristics, high electrical resistivity, increased specific heat, high thermal expansion coefficient, low thermal conductivity and superior magnetic properties. Explain the abnormal thermal stability in nanocrystalline materials. The abnormal thermal stability is illustrated by rapid grain growth at temperatures above a critical value, and this thermal stability depends on the material processed, and it can be prevented by adding dopants to the sample during fabrication. What is the meaning of tribology? Tribology is the study that deals with the design, friction, wear and lubrication of interacting surfaces in relative motion. What methods are used for the synthesis of nanocrystalline materials? The nanocrystalline materials in gaseous form is achieved by any of these methods, that is the inert gas condensation method, vapor deposition method and plasma processing method. Give the important applications of nanocrystalline materials. They find wide range of applications in energy, environment, sensors, in biomedical and biological fields, electronics, refractories. Catalytic applications are many, as coatings, in load-bearing structures, wear resistance and in military applications. Give some examples of nanocrystalline materials. The nanoparticles, graphene, carbon nanotubes, nanowires, metal oxide and dioxides, and nanosheets are some examples of nanocrystalline materials. Now we will learn about the nanocomposites. So what are nanocomposites? They are the solid materials where at least one of the phases shows dimensions in the nanometer range. The nanocomposite is an amalgamation or matrix in which different materials combines to develop new properties of the materials, ensuring that one of the materials have the size in the range of 1 to 100 nanometers. What are the phases of nanocomposites? They have many phases, which includes zero-dimensional, that is core shell, one-dimensional, which includes nanowires and nanotubes, two-dimensional, which is lamellar, and three-dimensional phases, which include metal and matrix composites. What are the parts of nanocomposites? There are two parts. One is the continuous phase and the other is the discontinuous reinforcing phase. How are nanocomposites classified? They are classified on the basis of either matrix or on the basis of their structural characteristics into three categories. State the classification of nanocomposites on the basis of matrix. On the basis of matrix, they are classified as ceramic matrix nanocomposites, CMNC, metal matrix nanocomposites, MMNC, and polymer matrix nanocomposites, PMNC. And the examples are given here in the slide. Please go through the examples of each matrix nanocomposites. State the classification of nanocomposites on the basis of structural characteristics. On the basis of structural characteristics, they are classified into three types, that is nanolayered, nanofilamentary, and nanoparticulate composites. State the properties of nanocomposites. They have unique catalytical, electrochemical, mechanical, magnetic, optical, and biological properties, which makes them excellent materials for various industries. Name the methods for the synthesis of nanocomposites. The methods that are generally employed are sol-gel synthesis, oxidative polymerization synthesis, thermal synthesis, microwave-induced synthesis, interaction, one-pot synthesis, template-directed synthesis, melt mixing, electrochemical synthesis, catalytic chain transfer polymerization, self-assembly, photopolymerization synthesis, reversible addition fragmentation chain, transfer polymerization, emulsion polymerization, and intermatrix synthesis. Where are nanocomposites used in industries? They are used as electrodes, as catalysts, in functional textile fibers, as drugs, electrolytes, biomedical materials, and in the fabrication of membranes. What are the environmental and agricultural applications of nanocomposites? The environmental applications of nanocomposites are as adsorbents, as photocatalysts, and sensors. They are also used in reducing the pollution as MONC, that is metal oxide nanoparticles in combination with graphene, silica, and carbon nanotubes for removal of dyes and heavy metals from the environment. In agriculture and food technology, the nanocomposites MONC are used as antimicrobial agents in food packaging, as sensors for detection of pathogen, as oxygen scavengers in the slow release of fertilizers for a prolonged period, and in the prevention of soil degradation. What are the applications of nanocomposites in health and medicine? In health and medicines, they are used in the delivery of drugs and imaging, in diagnosis and screening of diseases, in DNA sequencing, in gene therapy, in tissue culture, and in cancer treatment. So this was all about the nanocrystalline and nanocomposite nanomaterials. You can also write short notes if you are asked to write during your exams, taking all these points into consideration which I have discussed in this video. Keep watching for more such informative videos on nanomaterials and nanotechnology with me. Thank you.